Hello and welcome. I'm Bill Wake. We're here working on changing basically an evolutionary design experiment or exercise. We're trying to change from a recursive descent parser to a parser combinator approach in the basic interpreter we wrote a couple months back at this point, I think. We've finished expressions, or mostly finished expressions, and we've moved on to the statement types, and we're looking at def. So let's see, we did data, we did the one-word statements like stop and end, and we're working on def. And let's see, the E on there means it calls expression. I don't think that's quite so relevant now that we've finished expression in the new style. All right, but we'll use this as kind of a tracking chart to say what we've done. And we'll start with def and get as far as we get. All right, let me find, let's see, not so much interpreter, it's more parser. Okay, syntax analyzer. Yeah, so I felt a little balled up in this. We have define, and we've dealt with the matching. So this is the new style parser that uses these operators. So you match the def, you need to match the word function, fn, and then you need a variable. The arrow says, keep the one to the right. So this is the one we want to keep, and we still need a left parenthesis, and then a variable, and a right parenthesis, and an equals. And then after that comes an expression. So we're defining the statement. Now my insight, let's see if I could find this thing. We said, well, you're going to have to check it and then make a def statement, and we got stopped there. So my insight is, I think this check, we have an approach. Let's see. This operator is the check statement, and what it does is it feeds in the result of the previous parse and sort of a validation function. And if it validates, you return nil, and if it doesn't, you return basically an error. You return the position of the error and then the string, the message for the error. My insight is that these two often go together, and that separating them, I think, is unnatural. So I think my check statement is not as helpful as it could be. I think what it should do is you should feed in the parse so far and the position where you start, what you have left to parse, and then you should either return a valid new object with the remaining, so just look like a success is a valid new object and the remaining, or the error message and the position. So I want to kind of combine these two, and I think that will fit better in most cases, because a lot of times if you have validation, kind of the work to pull out all the pieces to validate it is exactly the work to pull out all the pieces to produce the new object. Okay, so what I'm going to do for that, that's less clear to me. I got parser adapters. I'm going to make a new type. Let's see. So I'll make a new Swift file, and I'll just call it Parser Combinators for now. This is kind of the missing stuff in my existing Parser Combinator library. So I'll backfill this into the library at some point. We have the check function, okay, and let's see if we can, yeah. So here you give it a function that takes a target type, and it produces this error message or nothing. And I think that's the wrong choice. So I'm gonna, let's see, let's steal the test too. All right, so Parser Combinator tests. You know what? I should probably put this in a new folder. Let's do that. group. Let's call it pcombo. Let's move this over here in there. Whoops, move the wrong one. It's in there. And down our test, we'll also make a pcombo group. And this is really just isolation. It's not a deep isolation, but it's just enough so I can keep those separate, because I think they are. This is going to roll back. So, okay, let's take the text here. Whoops, take all this. And we'll make a new file. Test suite pcombo parser combinator tests. And I probably should rename this too then. Parser combinator tests. Okay, and I'll just paste this and we'll. Okay. Testable import. I'm going to call this check 2 just to keep the name straight. And testable import BASI. We'll have to adjust that later. Okay. And this check 2 tests. And the date is 8/15. All right. So, satisfy, where's that coming from? Oh, I need to import pcombo too. Okay. Has member check success. That's true. Let's see. Do we care? Where's check success defined? Oh, we have an extension, I think. Yes. Let's just take this. Again, I'm kind of willing to do a little bit of goofiness because this will get integrated in and roll away. All right. So the difference is going to be that instead of pass, this has got the wrong signature. So in here, the usage, we're saying you should have one or more ones. Checked by some should be even, okay? And the prototype of this is what I want to change. So I want this to be values of int is fine because that's the input type. And let's see, the rest is the remaining. Which should be array slice, and in this case it's int. Let's call this remaining. So you're passing in the input stuff that this is the normal parser stuff going in. So, well, values is something, but the remaining is a slice of whatever you're parsing. And then the end result here should be parse result. And then let's see what where that's defined. Okay, it has an input type and a target type. All right, so in our case, the input type is int, and the target type, I will make string. Okay, and it's no longer optional. All right, so this, we have to generalize the signature a little bit, but this is the signature I want. Input values, remaining stuff to parse produces a true parse result over your input type and your output type. Okay, and so I don't want to return nil anymore. If it's successful, multiple of 2, I'm going to say result and then the sum. Okay, and if it's not successful, oh, sorry, this is a parse. Well, it's a dot success with result and the remaining. Okay, so remaining is the rest of the input. That's sort of a convention among the parsers we're doing, that they just pass along the rest of the input and the next parser can pick up there. In this case, it's a failure. Okay, so values count sum was odd. All right. Are you content? I think you're just behind. Oh, yeah. We need to define check. Okay, so let's go back here. I didn't put anything in here. Okay, let's find check. We're going to steal most of it. Okay, check 2 is a parser. Oh, wait, I still haven't done something in my tests right. Excuse me. Okay, cannot convert. Yeah, this is okay now. Right. Okay, so now when we pipe in sum should be even, well, we need to make sure this goes to a check 2 rather than a check. But the result of parsing that should be, what does check success say? Expected target, expected remaining. Okay, so now I want the string result 4, because that's the sum of the ones, and the remaining should still be the 2 input. Okay, yes, that's right. I think we're going to change this operator around, so it's going to look like this. Okay. Because now the value returning is the one coming from the right hand side, so I'm kind of flipping it for that reason. Okay, that sum should be even. Well, this one should fail. The failure is 3. No, yeah, 0, 1, 2, 3. It's the position 3, and the sum was odd. Okay. And this one, same deal. Pipe in greater sum. Did not find expected value. Didn't even start. I'm not a little bit. Check failure. You would think check failure expects a parse result. That should be able to infer it. I'm going to assume it's the issue is this operator, not the rest. Okay, so let's go back here again. Okay. Let me get this operator flipped. Bar and greater. And I don't know, the name of that is maybe not the best, but okay. So this, well, we're working on check 2. Check 2. Okay. Now, cannot find parser in scope. Okay, we need p combo. Okay. So now we got an input type and a target type. This function is target and yeah, this. That's the remaining input. And the result is a parse result of, I guess I shouldn't have deleted that too fast. Well, parse result of, and then parse result at input is p.input, and the output is a new target we haven't mentioned. Okay, so this probably needs a new parameter for target 2. Okay. And I'm kind of working my way through these, I don't know what you call them. They're generic, but they're using the type alias. I don't know. I should have a better word for it. I know there is a word. Okay, expected comma separator. I don't think that's right. I think we'll do a build. Expected a comma separator. Did I lose a paren? I think I did. Escaping target and an array slice goes to that. No, I don't think I did. Oh, no, I did. Okay. Because this is the function definition. Okay. Now this thing needs to be the same type as this. Okay. And I don't know if this will help a little. Okay. Cannot assign value. Good. All right. Check equals checker target. This is remaining. Remaining. Okay, we'll do something to mess it up so we know we're handling it right. Type of expression is ambiguous. Let location message. Okay, so if the first parse succeeds, we call our checker function, and it gives us back a parse result. This doesn't make sense. Yeah. Okay. Let's just return a failure here, and we can. We do have some tests we think will work or believe should do something. Let's see how else we're doing down here. Function specialized with too few types. Yes, this is target 2. This is parse result of P dot input target 2. And target 2. Is that going to be right? Check 2. Oh. Function escaping P dot target. This should be P dot target array slice of P dot input. Okay, is this build? First question. Oh, that's tests. Okay, now let's run these tests. Are they building? Cannot convert value of string to expected type. Many one satisfy target array of int. Well, that's the one on the left, which was the old way. Let's see. Parser target. Input target is not target, it's target 2. Okay, so we want to get the right-hand target because it could change types on us. And should. Does not conform to parser. Yeah, let's see what it wants. Parse array slice input. Input array slice input produces parser p dot input p dot target 2 is right. Target 2. So the parse should produce the new result type. Okay, build again. Parse. Oh, yeah. It's a different failure. That's kind of weird. Okay. This is failure let position let message, and then we have to make a failure of the new type, even though it looks exactly the same. Okay. P dot target to expected type target 2. Case success let target checker takes target. Oh, should take P dot target. So it takes the input type, the target of the first parser, and the slice. Okay. And so this should be target P dot target. But it produces target 2. Okay, so that's the transformation. Target to target 2. Okay, that's okay. Let's build. Oh. Still off. Okay, can I convert string to expected type? No, it's not. Okay. All right. Let's run these tests. And they should fail. Some of them should fail. The failure ones should pass. So I expect one failure and 2 passes. Okay, let's get in there. Well, okay, that shows you what I know. This one I expected to fail, yeah, because we just don't handle that case. This one I expected to pass. -1 is not equal to 3. Okay, this is interesting. So returns failure when the parse fails. Oh, This one passed. Good. Okay, so this one went down the other path. Yeah. All right. Yeah. Okay, I believe that's right. So the one that passed went down this path. We want to do this. So we get check, and then we're going to have to switch on check. Okay, so let's switch on check, and we could have a failure. Fail your do something and a success. Let target 2 and remaining. Okay, do something else. Okay, so if it fails, then we're just going to return a failure. But the failure is the maybe I've defined this in a better way. So the failure is the failure coming from the checker, and that's already the new failure type. So really, I just need to return this. That's kind of the benefit of the way we redefined it. So now it returns a parse result. So we're just going to pass it along. Okay. Checkers never used. Yeah, that's an old message. Okay, so now a little half-hour diversion there. We have this new combinator, and it's a check combinator that says, "Give me." Well, kind of look here. You're going to give me a parser, which is finding some expression or statement, and you're going to give me this checker function that I get an input type and the remaining input. And I will produce, a target type and the remaining input. Okay. And the way I do it is I run the parser. If it succeeds, well, no, let's say it this way. I run the parser first. If the parser fails, well, we just fail. If the parser succeeds, then I'm going to pass that to the checker and let the checker determine the result of the whole thing. Hopefully a new target value. Okay. Now, let's go back to syntax analyzer. So I'm going to put this new thing into use. Pipe greater that. Okay. And check def statement I think is okay, but let's. Okay. So token expression, that's the input side. Now we don't have make def, so that one goes away. All right, so check def, it has to be an input. That's the input. Let's see. Go to our test. This little function, it got 2 arguments. So it gets the values on the input, and then it gets this. And this slice is generic. So we can make it whatever we need to. Remaining. In our case, our input is tokens, so token is the type. And then this is a parse result. And I think it might, will it infer it? No. Yeah. Okay. The input type is token, and the output type is statement. Okay, because our goal on this is to deal with the def definition and produce a statement, okay, properly type checked. And so if it gets an error, it's going to do a failure, but otherwise it returns a statement. Okay. All right. So I think, I don't know, the name may be not quite right. All right. And I think what we have going on is this is the rest of the stuff. So this is the original require function, look for the variable. Notice it gets an error if it doesn't match the variable. Okay. And we need to check the name count. Okay. So that's something going in. The left parent is fine. The right parent is fine. But we have to do the expression require float type. Okay, so the result of the expression has to be a float type, and then we're going to produce this kind of statement. We'll take that. Okay, check def. All right, let's do it this way. Token expression. This is a little. We have to tear things apart, and I have an idea for that too. It would be nice if I had a function, like a flatten kind of function, that would turn those into 3 separate pieces. So I don't know. Let's see. We're trying to replace, so we're trying to make this a neutral thing. I'll do it the slow way first. So let tokens, well, let's do it like this. So we have to decompose this thing. Tokens expression equals argument, and then tokens, this is the function name, I guess we called it name, and the parameter equal tokens. Okay, so we're peeling apart that nested tuple. Okay, and okay, so this, well, let's let result equal that, and then we'll return success with the result and the remaining. So we're just passing a remaining through. Okay, binary output cannot be name dot string. Okay, parameter dot string. I mean some. Might need exclamations there. And functions. Okay. All right. So what I'm doing is I'm cheating. Okay. I'm going to comment these out. And this is where we're filling in semantics to match what we have. And so I took a shortcut. I just let check def statement it's not doing any checking. It's just doing the definition of the def statement. Okay. And then here, let's see, this is define returns a statement. So we want to say return wrap new, because that's what define parser is, a new style parser, and parse. Okay, so that says take all this stuff and run the parser. Oops. Can I convert value of check to expected type syntax analyzer? Oh, I need self. Okay, so all this stuff defines the new parser. We wrap it and call parse on it. Okay, and the wrap new and the parse and the try, they're conforming everything, the old style parser to the new style parser. Or sorry, the new style parser, making it act like the old one, where it throws things instead of returning a failure, and so on. Okay, this should pass at least one def test, but it should fail all the ones that check semantics. We'll run all the tests. Okay, 2 failures, def error messages, and I'm going to slide up just a little. Here's test def. Def function I of x equals x. That's perfectly fine, but we got an error message about the extra letters because we didn't require one. We're only supposed to allow one letter here, and this has 2, x9. Okay, and checking that it returns numeric. Okay, exactly the tests we should be making. All right, so syntax analyzer. So now we're going to find those checks here. Okay, here's this one. And we can do them one at a time. Let's call this name token, and then let name equal name token dot string. Okay, if name dot count is 1, well, this is a failure, and we don't handle it with throw. We would do a return. Return. And the position is really index of name token of name token. I'm willing to be a little off on that. Okay. And this whole thing gets wrapped in a failure. Type string must be unwrapped. Okay. And take that off here. Okay. And I'll just do the same thing out of kind of courtesy to myself. Token dot string. Okay. All right. So if name count equals 1, not equal 1, then we got extra letters, and that one test should pass now. The def error messages. Okay. And we have one more check. This one. Okay, so of the expression. And I don't know if I've called that before. Data Jeff check. Okay. Float type of expression. So expressions type is expression, and require float type. I guess let's go find that thing. Okay, it throws and gets a message. This is kind of clunky. I think let's... Oh, we have one. Oh no, Parser. Okay. Well, we can catch it. That's fine. There may be a better way, but let's do a do. Try this. If we catch parse error, it's index. Let position, let message. Got extra paren. Okay, then we have to catch anything else. Okay. Parser cannot be constructed because of no accessible parse. Dot error. Okay. Oh, it's a token. Token let message. Okay. And this is a little tricky. The position may be off. All right. But we are going to return a failure, an index of token, and the message. Okay. And then this is unfortunate, but I think we'll return parameter token because it's kind of fallen apart. It's kind of a can't happen. This is a shouldn't happen. Well, I'll call it can't happen. Unexpected error in require float type. Okay. It's awkward to have to catch things this way, but let's see what happens. And again, I think the index may be off, and I'm kind of willing to live with that. Nope, we got it right. Okay, let's find that test. Let's see. It's a parser test. Def user find. Okay. Yeah, we're mostly checking the message. We're not particularly picky about the position. Okay, good. All right. So we've done our def statement. All right. Now, normally the Parser Combinator thing saves a lot of space. This one saves a bit. I mean, that's, let's see if I do this and compare 282. Well, let's get down here. Okay, 312 to 340, like 28 lines. So what's this one? 310 to 326, 16 lines. We've saved a dozen lines. I guess that's something. Usually we save a bit more, but all right. So that deleted the dead comment. Let's make sure we're good. Okay, so handle def statement with new parser. All right, and then, I don't know, do I want to do them in order? Let's take this out, copy this, give ourselves a check mark for that. Trying to think if there's any advantage to doing them in a different order. I don't think so. Let me change my mind tomorrow, but for today, let's go on to dim. And takes an expression. Okay. Dim. Oh, here's dim. Okay. All right. Okay. So dim statement is producing array of dim infos. Okay. So our parser We're going to match, we'll match the first thing. Let's see, let's compare. I guess it's down this way. My alphabetical skills are apparently not so good. Where did define go? It's like 460, right? We were up a ways. Oh, here's def. Okay. Define. Right. We're going to match the front, and we got to match all those pieces. Okay, so let's find dim1 again. Okay. So we match dim, and the statement is, oh, well, maybe let's start on the inside. Okay. So this is match dim and then get a comma separated list of dim ones. And a dim one is, this is the variable parentheses and the contents, the expression separated by commas. So each expression is a dimension size. You can have multiple dimensions on the array. So let's see. So this is, we're doing a variable. So let's match variable with followed by a left parent. And let's see, after that, followed by, and this is expression, comma, expression. Okay, yeah, so this is match expression parser, and then this match comma. Whoops. And this one, we don't need to see the comma, so we just keep the left-hand side. And that whole thing, okay. So match a variable followed by, I'm gonna make this optional, the left parent optional. So I don't care about the left parent, I just want the right-hand value. And I'm trying to format it to look that way. Okay, so match a variable, keep the variable, ignore the left parent, but it has to be there, followed by a comma list, okay, followed by a right parent. Okay. So that's our parser. Well, let's do that. Let's let parser equal that. Cannot convert bind expression to argument token type. Oh, right. This is just expression parser because it's a parser. Okay. And that. Okay. So now that should give us a, it should be a tuple with the variable and an array of expressions. Okay. And we have to enforce some stuff. Well, if nothing else, we have to return the list of expressions. It looks like we're not enforcing anything else. Okay, so I think we can use this form. It's just a transformation. Okay, and it's going to be called make dimension. And it's going to take an argument that's a tuple of a token and a list of expressions. And it's going to produce what's it going to produce? It's going to produce a dim1, I think, a dim info. produces a dim info. Okay, and let token expers equal argument, and then these are dimensions. And we'll let array name equal token dot string. That looks better. Okay. We will pipe that to this function. Make dimension. Okay. And now I think we can just call it. So return try parser dot parse of input. I think it's just parse it up. Oh, we got a wrap new. Wrap new self parser dot parse. Is that right? Yes. Okay. And then this stuff. That. Okay. This should be neutral. Okay. Delete that. Should still be neutral. Okay. And we should be able to push this. So handle dim1 with new parser. Okay, and this one. Okay, so this. Well, we need to match. I guess we'll make a parser again. Let parser equal match the dim statement. We don't care about the dim so much, so we're just going to take the right-hand side, and that is dim1 separated by commas. Okay, so dim1 repeated matching commas. We will have to fix dim1 there. Well, let's do that. Let's just take this. I'm going to call it dim1 parser. And we'll call dim1 parser. Okay. So we've got the new parser for dim1 here. We match this with that, and we're going to pipe that to a make dimensions. And make dimensions is really notice it's just creating an array of dim1s, and there's no further checking or anything like that, so that's fine. Well, and this thing, its input is array of dim infos, so it's practically there. All right, so these I'm okay to just say dot dim of $0. I may need some more types to clarify, but let's see. Is it good? Okay, it's good. No, I can't infer. Statement.dim. Okay. So we'll take the parser and run it through this, and it builds each statement. Okay, and we return, we do try wrap new self parser dot parse, and that makes us like the other one. And that's a return. Okay, that should go away. Good. And run. And again, should be neutral, should just pass if we've done it correctly. Okay, so now dim1 parser, no one's calling dim1. Okay, so let's take that out. And make dimension, we need wrap new. Okay, but that should be neutral. Should be, whoops. Somebody call it directly. Dim statement. Oh, we did. Oh, we had already kind of done this one. Okay. Let's find our dim again. Whoops. Dim here. Okay. Let's call this dim parser. And I'll take it back. Let's create a dim parser. Dim parser returns parser. And let it do this. I thought we did this somewhere else. Find arrow parser. No, what's the type of this? Can I do this? Parse. We want bind token statement. Okay, so this can become all right. This can just call dim parser. Okay. We still got to build it. Okay. So dim statement, I'm just going to say is dim parser. Where's it calling it? Oh, there it is. Okay. Okay. We're still messed up. Wrap new. Oh, we don't need to wrap it anymore. No, I messed up something. Dim parser. Okay, let's see the type of this. Well, this thing should be a new style parser, so I don't see the issue there. Dim parser parens. Okay. Now it should work. Okay, now this is can't happen. Did we get any can't happens? We did. Okay, we're still not quite there. Right parent error and dim. Let's see if that's the only one. Yeah, right parent error and dim. Well, let's see how our parser is doing it. Yeah, if it gets an error, it's doing that. I think we want to change this around. Okay, because I think now we have a full parser for this. I think we just want to return the result of that. It's supposed to work. Okay. It's supposed to be properly wrapped, and it's supposed to have errors if it should have errors. So let's see if this passes, and we should no longer get the can't happen. Okay. Happen. Okay. Good. All right. And dim statement is just this. Let's inline that. Handle dim with the new parser. Okay, good. All right, let's move this. Take a check mark. All right, we've been going a while, so let's go ahead and take a break. We'll come back and pick up with the for statement. Let's see here, do for. And yeah, that's got a little complexity to it. It's got some checking. So we'll tackle that. All right, so see you in about 3 minutes or so. Welcome back. Okay, let's get going on the for statement. So again, we'll make a parser. A for parser equals, and it's going to match the for. Let's see, and then a variable. And again, we don't care about the for, so let's just do the variable. And an equals, and again, we care about the variable, not the equals. Equals. Okay. For variable equals, and initial is an expression parser. Let's see. So these three go together. They result in one variable for us. And next we need an expression. Followed by a to statement. We don't care what the to statement looks like. Match of two. Expression match two. Well, actually, I think that's probably more like expression. And then match two and expression parser. Okay. So for variable equals expression to expression, and okay, and then an optional expression, step expression. Okay, so this is and optional match step followed by expression parser. Okay, what else? Actually, that looks like it catches the syntax. For variable equals expression to expression, and then optionally step expression. Let's see. So we match the for, we throw that away, but keep the variable, keep the expression, keep the second expression, and keep the third expression if it exists. Okay. And this has semantics, requires float type. And it has a build. So we need our new maker, this guy. Okay. And this is make for statement. It has an argument of type. Well, it's got a variable, so it's got a token. It's got the first expression. Then that's all in a tuple with another expression, which is all in yet another tuple. This is the annoying part of an expression optional. Okay, because the third expression is optional, and we keep the expression. Okay, we're not quite done here. Make for statement. And it produces a parse result of token to statement. Okay, and I'll just return skip for a moment. Target 2 could not be inferred. Token expression 2. Usually it tells you what type it thinks that should really be. Okay, target 2 could not be inferred. Target 2. I don't understand why that's not token. Well, okay, I've screwed something up. 3 tokens. 1, 2, 3 parens. Need one more. Whoops. One more. Is that better? Why did the build fail? Oh. Statement. Oh. Okay, needs parse result. And this is still not happy. Operator function and requires and tuple and optional be equivalent. It should not require that. Yeah, there's something not quite right with these and then tuples. I don't know if I'm just getting beyond the depth it's comfortable with, but that seems unlikely. Optional. We may be able to break it into pieces. For start equals this stuff. Oh, excuse me just a minute. All right, sorry. Let's see. Let's pick up this much. That much. Whoops. Match the 4, and then this needs to be for start. And that. Okay. Oh, it's just slow. Operator function requires and then tuple, and then tuple. So that's got the two tuples. Token expression. That part looks right. I don't know why it wants them to be equivalent. Array of optional. Let's see what result type optional has. It should just be optional target. Cannot convert value of token expression question mark to expected type. All that stuff. This has optional. This is confusing to me. this should be optional. Sorry, it should be optional, an optional array of targets. Not even an array, is it? Just an optional target. Why? What's a bracket? Yeah, I don't know why this bracket is here. See, I think what it's doing is there's if these types were the same, so if it was let's say it was producing an expression, let's say this one produced an expression and this produced an array of expression, then it it will try and turn them all into one big array of expressions. But and that appears to be what it's trying to do. It's trying to say this should be an array of optionals. I don't know. I mean, it's so I think it's confused. I think it's saying I've got an element and I've got an array of a different element. I want them to both be the same element type so I can fold them into one giant array. So I'm confused on two fronts. One is I don't know why this is an array when it's clearly producing a target question mark. Expression parser just produces an expression. So I don't understand why this is coming up with an array. And then once it has it, I really think if this type is different, it should just say, oh, it's two different types. It should produce another tuple. I mean, that's what it did up here. It said I had a token and an expression. They're not compatible, so they must go into a tuple. So I really expected this to be token expression, and expression optional. Why this thinks that, though, that's got me confused. It produces an optional, and the optional says my input type is whatever the input, in our case it's a slice of tokens, and my output type is the original type input. Okay, so let's break this apart a little more. Let's get this piece. Equals that. And let's see what his type is. He's a then keep right satisfy bind token to expression. So that should be bind token expression, which should be expression. Okay. And we'll do this. We'll say step parser. Why that's optional. And my real problem with this is this and parser is just growing because there's just so many variations. Let's see, that's test. Let's get the parser itself. I may be able to do something. The bind gives me a way out. Maybe I can do something with that. But all right, let me go through the variations. I don't know if this is helpful. If you have P1, P2, their inputs have to be the same, but basically by default, I just create a tuple. Okay, I think that should normally apply to those. Then I have the case where the input is a single type. Sorry, we don't care about the input. The target of the whole parser, they have the same type. So if I do 2 tokens, I'm going to get an array of tokens back. Okay, so that's element gives me an array. This one is array, then array element, then array of element. So P1 is an array, and P2 is an element, and P1's type is array of P2. Okay, so array element. And then this one is the one I think we're triggering, element array. P2, well, P1 is an element, P2 is an array of element. Then we produce an array of element. And I think this parser is the one that's getting in there. And maybe, see, I don't think I could put a not here. Really, I want to make another case that's P2 not equal that. If they're not equal, I don't care that it's an array. It's just not going to help me. And that should become like the tuple case. But I don't think I can do that. Let me try. But I think that's the tuple case. Let's see. I think my tuple case, I want to say, I don't know. Is this a diversion? Can I work around it? Maybe I should work around it if I can. Yeah, let me try that. So I'm going to use bind. Bind, the input is token, the output is expression optional, and it's going to take step parser.parse. Okay, so I'm saying, oh, I still don't like it. And then tuple, an optional bind token. Why is that an optional? Oh, let's take it on the other side of it. Okay, this is bind. Input is token, output is expression, question mark. And the parser is this. Oh. Undo. Ready to paste. Ready to typing. For start. Okay, I think I'm back. For start. That is parenthesized. Oh no. Okay. Let step parser equal this. Okay. And now we can do bind token to expression optional on the whole statement. Not sure it's going to help, but it might. Okay, so what bind is supposed to do is, well, one way it can work is it lets you defer defining the parser, but this time we're saying I have the parser already. It should take away, like this thing has complicated stuff. It's got all those things in it. It's an optional and so on. This one is simplified. It's really just token expression. Okay, now let's see if we build. Oh, he's still messed up. And then tuple, and then blah 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 blah. To be, why is that an array? Okay, let's do the same thing here. Bind token, and the type of this one is it should be token expression, token expression. Bind tuple token expression expression. That's its stuff. Parse. Okay. So I'm kind of trying to, I don't know, I want to say trick, but I'm trying to convince, maybe. Bind token 1 2 1 2. Bind token, and this is pair token comma expression. Okay, bind token expression and array of bind be equivalent. Let me take this out for the moment. Make sure that's not interacting. Because it is. Okay. Maybe I don't need this then. Okay. Cannot convert token expression question mark to expected argument type. How does it get all that stuff? Oh, let me put the bind back. Token expression. Whoops. Bracket for start dot parse and that. this make that fall apart? Make for statement takes token, expression, expression optional. And I think that's what this is. And then tuple, so it should produce a tuple of this with this. Okay. I'm gonna split it up again. Expression, comma, expression optional, bracket of for parser body dot parse. Okay. Should be neutral. Okay. Problem is I'm not using it, right? Right. Now if I pipe that, build, cannot convert bind token expression. Wait. Token expression, optional expression, array slice of token to parse result. Have I got my operators mixed up? I don't think so. Can I convert token expression optional? Goes to parse result statement to expected type. Bind, it's really the other way around. Bind token expression optional. That looks the same to me. His target is that stuff. Array slice. Oh wait, bind token. Have I got the order wrong? Array slice of all that stuff. Dot input. Okay, which is token. Bind result token. I've left out an argument. Golly. Remaining of array slice of token. Oh, golly. Okay, let's unroll this. Let's take the bind out. Okay, let's this is for start and step parser for start and step parser Expected parentheses in expression list. For parser. For start. And what the heck? Expected per. Oh. Must have bumped it. Okay. Oh, dear. This parser combinator thing is definitely harder to debug. And it's interesting to me that it makes it look like the error happened above, even though it really happened in my definition of my function. Kind of like, wow. All right. So if I were to say return try for parser, let's see, wrap new self for parser dot parse. So I'm kind of relying on my tests. This should fail because our for stuff doesn't do any of this. Okay, so he's got index out of range. So, okay, so something about the failure index. Oh yeah, we return minus hard-coded -1. Yes, that's pure failure. That's fine. Okay, now let's peel these apart. And we're going to do this without the semantics like we did last time. So well, maybe this is where I do this. Let variable expr1, expr2, expr3 optional equal, I'm going to say flatten of argument. Okay, and flatten, and I think the types are, I don't care. It takes an argument of T1, T2, comma T3, comma T4, and it produces a flat T1, T2, T3, T4. Okay. Return, well, let T1, 2, 3, T4 equal argument. I don't think I can do this in one line. Let me try. Let T1, comma T2, comma T3. Can I do that? Oh, I can. You can't do it in the declaration, but apparently you can do it here. Okay. Is that legal? Yes. Looks like it anyway. All right, so we're going to try and return a for statement. with variable initial final step. Okay. Statement.for variable initial final, and this is the tricky one, step optional. I'm gonna have to do something about that. It might not be present. Okay. If let's say let step if it's nil, then it's down here somewhere. It's a 1. Okay. Oh yeah, it's a parse result. Let statement equal that, and return success of statement and remaining. Okay, so this should pass some statements, some for loops. Well, I was going to say it should pass some of our tests for loops, but not the ones that check the statement stuff. Yeah, we got to get string here, and I think I can leave the exclamation off. Sometimes you can, and sometimes you can't. Okay, that built. Okay, so we should see some failing tests is the point. But not every for loop test should fail. Okay, good. I'm sure there's more than 2 for loop tests. Yeah. So without step or with step, we got that computation right. Defaults to 1. And there may be some more. No, that pretty much covers them. Okay. Syntax wise. For requires numeric. Variable equals and 2. Oh, this is okay. Missing expected character is less ideal. I'm okay with changes in the error message. And this one in particular, missing variable name, that's perfectly fine. Missing expected character is not really quite what I would like. Okay, but let's get past those. For requires numeric expressions. Yeah, that's more to the point with this one. Okay, so here's our match. Match the token variable equals is required. Okay, we can put the message in there. Match this equals is required. Okay, let's see if that makes the 1 pass. Yeah, that took care of that one. And then the 2. This one I'm less sure about. Oh, I didn't update this, did I? New def parser. New dim parser. And we're working on a new for parser. Okay, but that's not our problem here. 2 is required. I hope this will get matched. Good. Okay. Now numeric type is required. That's more semantic. Okay, require variable. Expression. Okay, require float type on initial this and step. Okay. Let's put this in a do catch. Okay, initial, final, and step. Okay, so all 3 expressions. So we catch parse error dot error. Okay, and if this fails, it's a parse result failure. So return failure, and we'll take index of token and the message. And then if it's another failure, we don't, it's sort of a can't happen thing. And the message is can't happen, require float type, failed. Okay. That catches up. Okay. Again, the indexes may not quite be right because expressions and all that don't come with positions, but the message should be the same. Okay. All right. Handle the for parser. New style. Okay, let's move on. Take that out of the way. This. GOSUB. That's a nice straightforward one. Let's hope it comes off that way. Okay, so over here, we've done this one. We should have a new GOSUB parser. Oh, did I call that parser? Wait a minute. We did. Let's clean this up. This we should probably do more of. It's one thing to pull these out. On the other hand, is that as helpful? Since it let me do this, that's not that bad. I thought I was going to break them up one at a time. So let's just put this back. Variable initial final step optional equals argument. Okay, and that's a inline. Deconstruction, I think, is the word I'm looking for that. Okay. GOSUB. Oh, wait. Do for does that. Okay. Why is do for down here? Dim. Well, it looks a little out of order to me, but I think, again, we'll sort it out when we finish all this. Okay, GOSUB. Right, so GOSUB looks for an integer, and then it converts it, and if it's not there, Okay, I think this will be a little different. Okay, so we match let's see. Let GOSUB parser equal match GOSUB. Okay, but what counts is okay. I think the way to do this is match integer. And if that's not found, maybe we can do this. Yeah, I think that's what I want. I don't think I need the parens. Okay, match the GOSUB, match the integer token type. Then to convert it, it's this, and we're going to say dot statement dot GOSUB of line number of $0, which is a token, dot float. Okay, and we call this return try wrap new self GOSUB parser dot parse. Okay, delete that. That one's done. Test run. Nice to have an easy one. Okay. GOTO should be just as easy. GOSUB, GOTO, okay. Right here, okay. And boy, that code sure looks similar, doesn't it? Go to parser, match GOTO. And really, I think we can just take this. Match integer missing target of GOTO. Return a GOTO. And call GOTO parser.parse. And we're going to live a little and just try it. Good. If, oh, that's going to be a complicated one. I'm going to save that one. We finished GOTO. Let's skip forward to input. I want to start in if when we're on a fresh day. Okay. Let's see. Input. Do input. That's different. Oh, no, it's not. Okay, well, that's more than I... Okay, we have to do a little looking around. Okay, so the input is, well, let's input parser equals match of input. And we want to keep, all right, the right side is an optional string semicolon. Okay, so this is an optional string. Keep that, and then a semicolon. And then we have a message. Match the semicolon, close the inner one, close this one. Okay, so match input, we throw away the word input, and we're left with an optional string, and then followed by comma list of variables. Let's see how bad that is. Variable, at least one variable is required. We may not get that message. We'll see if we can do it, but I'm gonna input. We next require a comma list of variables. Let's wrap that. Wrap old self with comma list of variables. Just the method name. Okay. And comma list of variables, wherever it got to. Returns a list of expressions. Okay. So this whole thing, well, he looks like he's not really enforcing anything else, so I think we'll just use this one that says optional prompt defaults to empty. That's a little more work. Let's make a method. Make input statement. Okay, this one's just transforming an argument of, hopefully it is string optional and expression? Wait a minute. Yes, expression is right. Array of expression. Okay. And that should produce a statement. Can convert string expression to expected argument type. Blah, 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 blah. Blah, blah. Oh, I guess it's a token still. It's not a string yet. Okay. Yes, good. Okay. And we'll just return statement.skip. Oh, now it's complaining. Can I return? Oops, no. Okay. Let's build. Good. Okay. Right. So if we guess if we call this return try wrap new of input parser dot parse. Okay, this stuff gets commented out. We need to return, we need to figure out the prompt given the token, and we got the variables. Okay, so we will let token expers equal argument. This is token optional. If token optional is nil, then we'll return empty string. Yep. Let prompt equal. If token optional is nil, then empty string, else token optional dot string. Okay, and we're going to return dot input of prompt and expers. Okay. This should pass. Oops. Okay. At least one variable is required. Now, why did it like that? This all comes down to the backtracking nature of things. I think what's going on. Okay. I think it comes in here. It matches the word input. It matches the string. It can't match this. And so it says, yeah, that's this just failed. This isn't present because I don't see these two pieces. But and then it says, well, okay, let me go on and try. This was optional anyway. Let me go on and try this. Let me try the comma list of variables starting at the string because it didn't match the whole component. And I think at this point it I think it fails here and then comes back here and says, okay, match the variable, but the variable is still on the string. And it just thinks, oh, that's just not going to work either. So I think maybe it's not getting credit for this. But I don't know how to get it to... I don't know. I may... I wonder what happens if I put the... Can I put... Let's make some pieces. I don't know if it'll get further though. So one idea was, what if I said you could match prompt semicolon variables or just variables? But I don't think it's going to get any further in the match. Okay, yeah, let's try it. Let prompt plus variables equal, and let's take this piece. Whoops. And the variables. Okay, so this thing, and then we're going to throw away that piece. Well, I think this parses the same anyway. Let's see what his type is. Tuple, the keep left, and a wrap old. Okay. So I think that should be okay. The funny thing is they're not. Once you mix this in, it's not associative. If you just had these, it'd be associative. If you do this, it's not. So these two match this and produce the string, and then it's a string plus the comma list of variables. Okay, so what I'm going to try is I'm going to do two things, and we'll see how we like it. Okay, so this bit is prompt plus variables. Okay. So this becomes that or this. Okay, so it's either prompt plus variables or wrap old. Ambiguous. That's true, it is. Ors have to produce the same type. Okay, this may be more than I want to get into. There is the notion, like I could inject the default prompt and follow it with this. I don't know that I have one. I don't think I have an inject. I don't think we did that because I didn't know if it would really be useful. Okay. What that would look like would be inject. What would I be injecting? I guess it's got to be a token to match the other one, and the token is dot string of nothing. That and that. Okay, and the inject is new. Okay, so let's. I just don't even know if this is going to work. Glasses are just horrible here. I have a couple of theories, I guess. Okay, this may or may not work. I think inject will make sense regardless and is reasonable for my thing to have, because sometimes you want to make two branches conform, and inject allows you to kind of boost that along. So let's do inject. This whole approach may not work, but it may be that I can turn, maybe if I do the alternatives in the backwards order, it might be okay. Or I also have something that can like let me put an error message on two alternatives that sort of combine a combined error message that would say you must have an optional prompt followed by a prompt semicolon, and then a list of variables. So I could do a generic message, and I think I'll take that if my approaches don't work. Okay, so let's go to Parser Combinator, Pacombo. I'm going to define a new parser. Okay, and need a test for it. Combo tests. Okay. I think I can make a new class. This is going to be called inject. And the casing's a little weird because it's just how I'm making it work, but it makes the program read right, even though it's unusual that you have lowercase for a class name. Okay. Let's get a test. This will be kind of a happy path. Maybe there's only one test. Test injects value before parser. Okay, so a 1 matches a 1, and we're going to say inject token string. Sorry, it's dot string. We may have to say token dot string. And 1. Okay, so this thing should make an optional injection of the words. Sorry, it should make an injection of the word string and then parse the value 1, and the result should be a token string and an integer 1. Actually, we don't need this because the type is going to be generic. String. Okay. So you'll inject a string with an integer, and that'll have to become a tuple. Okay. And that won't build. Until we create a new parser, and I'm just going to steal everything. I don't need an operator for this one. Okay. Inject a parser and a target type. It's not a target, it's a injected value. Okay. The target of our parser is going to be injected value and p.target. Okay, so make a tuple. Is that useful enough? I hope so. Okay, we don't need a checker function. We need a value. Okay, so if you give me a value, value of type injected value, and a parser of type P. I don't need that stuff. Okay. Then I will give you a parse result of input and target. Input target. And self.value equals value. Okay. Consecutive declarations. Init value. P produces parse result. That's also extra, isn't it? Okay. Then the parser takes array input of input type and it produces a parse result of target type. Okay. And I don't think I need to say p.input because there's no ambiguity here. Okay. And let's just put a fake failure in. Failure -1 and TBD. Okay, so this test wait a minute. I got some build errors here. Missing argument. Oh. I'm being more complicated than I need to even. Okay, I don't need a parser. It is a parser, but I don't need one here. Since I'm just reading no input and I'm just injecting this value in. Okay, it takes array slice of input and produces input target. And okay, we're just going to return something. Well, for now, let's just return failure -1. Okay, is that build? No. Cannot infer beverage member string. Okay, that's token.string. I'm not even using these. Well, I am. Let's uncomment this. I just want to get myself straight here. And comment this. Missing argument from parameter 2. That doesn't sound right because I just got rid of that. Generic P could not be inferred. That's possible. Oh, I don't need a parser. I need a input is that right? I'll tell you what, let's stop here. Explicitly specify check P of parser. No, we don't really want that. Input. Do I need that? that can be set. That's fine. Let's do a clean build folder and a build. Type inject satisfy int. String int cannot conform to equatable. Did I say array slice in there? All right, well, obviously I can't solve this in 0 seconds, so let's call it a wrap here. We will pick up here tomorrow. So tomorrow it's 10 a.m. Eastern Time to 12:30 p.m. Eastern Time, or 3 to 5:30 p.m. UTC. Thanks for joining. We got through a number of statements, and we'll pick up with input tomorrow. I thought it'd be an easy one, but it's not. Okay, and have a good evening. Take care. Bye-bye.